Hello, it's Professor Johnson. Welcome back. In this video, we're going to talk about the three different t-tests that we've learned about, how to get SPSS to produce output associated with each of those t's, and how to think through that output when it is provided to us. Let's start with the one sample t. We're going to start here by assuming that you know when it is appropriate to perform this test. As you know, we're going to have one sample that's measured on some dependent variable that is either interval or ratio. And the null is that our sample comes from a population with a known mean, often abbreviated with the Greek letter mu. So this under the null says this is what our sample came from, and we're going to test that null hypothesis. A few reminders here. The data for this study will all be put into one column, right? So we have a DV. Each thing that we're measuring provides one value on that DV, and that's our sample data. And the variable needs to be what SPSS calls a scale variable. It's either interval or ratio. And as you know, it's very important when you do a one sample t-test to make sure you remember to tell SPSS what the mu is under the null. If you don't do this, it defaults to whatever was last used if you've run the procedure in this session. And if you've started it fresh, it starts out with a default of 0, and it's rare that you're really trying to test that. So let's talk about a situation where this might be an appropriate test to do. The Pew Research Center reported that in 2013, Americans who are 18 years or older read a mean of 12 books. Let's ask the question of whether we think faculty members look like the rest of the world when it comes to book reading. We're going to take 20 faculty members at a liberal arts college. We'll randomly and independently select them and ask them how many books they read in 2015. So our research question here is, do faculty members read books in a fashion that is similar to Americans as a whole? Our null hypothesis is going to be that they're just like everybody else, which means their mean at the population level should be a 12. Now we understand that because of sampling error, our sample of 20 might have a mean that's different than 12, even if faculty on the average do read 12. So we need to not just know what the mean of the books read for the 20 faculty members. We need to know whether, based on the variability in the sample and the mean, that when we compare it to this population mean, do we have reason to think that they might be different at the population level. So let's go over to SPSS. Here we have a variable, books read. And you can see a label has popped up. These are our 20 individuals, so each person providing a data value for us is in a row. The column is the variable of interest. If we go over to variable view, see I used a very simple variable name, but I actually gave it a longer label, books read by faculty in 2013. It's a scale measure. I don't have any value labels. No decimals in my data set, so I just put that at 0 to make it look a little bit prettier. Now I'm going to analyze, compare means, one sample t-test. We have two jobs here. One is if we have lots of variables over here, we need to pick the one that we really want to do our one sample t on. This is our sample data. We put it in the test variable box. But before you click OK, this is the important piece to remember. This is mu under the null hypothesis. So this is the population mean that we're going to be testing this sample mean against. And as you recall, the setup is that at the population level, the mean is 12 books a year. So we put 12 here, and we're going to ask the question whether our sample is representative of a population that has a mean of 12 or if there's something else going on. I'll click OK. Tells us what procedure it ran, one sample statistics, tells us we're doing a one sample t, 20 values in the data set, the mean is 39.9 books read each year, standard deviation 22.95. This in SPSS is the sample sum of squares divided by n-1 and then the square root of that value. Here's standard error of the mean. This would be and actually it's the estimated standard error of the mean, and this would be the denominator of our t. So we would have 39.90 minus the 12 under the null divided by that estimated standard error of the mean. We have a t with 19 degrees of freedom that's equal to 5.44, comma, p is less than 0.001. And again, even though we see 3 zeros here, we know that it can't truly be 0. It's some other value, in this case 0.00003. It's a rare event to have a t this large with these degrees of freedom, but it's not impossible. If you want to report the 95% confidence interval of the difference, which I encourage you to do, it's here for you. So this is the value we're comparing against our alpha, which is usually 0.05. We would reject the null hypothesis here. We have the sample mean and sample standard deviation that we can report as part of our descriptives. And we have, again, a t, paren 19, close paren, equals 5.44, comma, p is less than 0.001. Reject the null hypothesis. They read more than the population mean of 12. Perhaps not surprising. Let's clear these output out and go on to our next test. The independent samples t-test, or the independent groups t-test, is appropriate when we have two samples and we want to know whether those samples come from populations with equal means. Or you can think of this as, are they two separate samples from the same population? However you like to chew on this idea. So the reminders here are that because this is an independent samples, this is telling us that each person is going to provide 1 and 1 value. So if you're in condition 1, you'll provide a value for us in condition 1. If you're in condition 2, you'll provide a value for us in condition 2. So we're going to have two columns because SPSS needs to know for each measure on the dependent variable which condition does it belong to. So one of our columns will be a grouping variable, which is going to indicate the level of the independent variable for each row. And then a dependent variable, and as you know, because we're doing a t-test, this needs to be interval or better data where the t would not make sense to do. Let's talk about an example. Snopes.com claims that it is a legend, in fact not true, that green M&M candies are an aphrodisiac, but they don't really provide any empirical test of this idea. Anybody who's had green M&Ms knows what they do to one's libido, but let's actually get some data here. If you get lonely and want to read what Snopes has to say with it, there's the site. So we're going to take 40 adults and randomly assign them to one of two groups. That's our clue, right? Randomly assign to one of two groups that we have a between subjects design, and because there's two and only two levels of the independent variable, it's reasonable to do an independent samples t-test as long as our dependent variable is interval or better. In one of the conditions, people will consume brown M&M candies. And in another condition, they will consume green M&M candies. And then 20 minutes after consuming the candy, all participants will complete a sexual desire questionnaire. And we're told in the literature that this is an interval measure. And the IRB approved this, and we're not going to get anybody in trouble here. Oops. So let's go to SPSS. Look at how we've set up the data here. So we have one variable, candy color, that is coded a 1 for one group and a 2 for another group. These don't have to be 1 and 2. It could be 0 and 967. It just needs to be a dichotomous way of coding them. And then we have a dependent measure. So this is the name of a variable. Here are people's ratings of their sexual desire for condition 1 versus condition 2. We go over to variable view, you see that not only have I actually come up with longer names for our variables on the label box, for the independent variable, I've provided value labels so that a 1 is brown and a 2 is green. This is going to allow me to interpret my output much more easily than if I had not labeled this independent variable. So we're going to go to Analyze, Compare Means, Independent Samples or Independent Groups t-test. So between subjects design, two levels of the independent variable, a DV that is interval or better. The test variables, and we could put in multiples, so the plural part, but for us the test variable is our dependent variable, our sexual desire measure. The grouping variable is what keeps track of what level of the independent variable each value came from. Okay. And because you could do a t-test on a variable that has many different levels and values to it, SPSS needs to tell you what the two groups are in terms of the specified values in the data set, even though in this case there were only 2 to choose from. We still have to tell it. So we had group 1 as being a 1 and group 2 as being a 2. Continue. Okay. Let's go over to our output. It's doing a t-test. The fact that it's talking about groups and independent samples tells us that it's an independent groups or independent samples t-test. Here we have the descriptive information for our 2 samples, 20 individuals in the brown M&M condition, 20 individuals in the green M&M condition. Here are our 2 sample means, standard deviations. Over here, we first see the Levene's test of equality of variances. If this were to be less than 0.05, it is not reasonable to assume equality of variances, and so we would be dealing with the adjusted degrees of freedom and this bottom row. But because our significance for the Levene's is greater than 0.05, we're safe assuming equal variances and can stick with the top row. We have an observed t-value with 38 degrees of freedom that's equal to negative 1.34, comma, p equals 0.188. So in this case, we're going to fail to reject the null hypothesis because our obtained p is less than our alpha of 0.05. These data at least do not support the argument that green M&Ms change anything about your sexual desire, at least in relation to brown M&Ms. If you want to produce a confidence interval, I encourage you to do so. It's already done for you here. As you know, the negative t is simply there because of what we decided to call group 1 and group 2. It just means that the mean for the brown was less than the mean for the green. If we had switched the order of those, we'd have a positive t. So we don't really worry about the sign of the t. We care about its statistical significance. Again, let's just clean this up and go to the paired samples t-test. In the paired samples t-test, which comes from a repeated measures design with 2 and only 2 levels of our independent variable, a dependent variable that is interval or better. In this case, each individual in the data set provides us 2 values on the same dependent measure. Right? So there's a condition 1 and a condition 2, so each person or object of interest is measured twice. And what we're really testing has to do with the difference scores. So for each contributor to the data set, you can think of them as contributing a delta score or a difference score. And the null is that at the population level, those different scores have a mean of 0, meaning the independent variable doesn't do anything, and or the grouping variable isn't associated with any differences at the population level. SPSS wise, we're going to again end up with 2 columns, but very different 2 columns than we had with the independent groups case. Right? Here we have 2 dependent measures from everybody, or dependent variables. So each person gives us a score, and each row is a person or an object. So our first column is going to represent one of the dependent variable scores, call it condition A. The second column is going to be the dependent variable scores for condition B. The dependent variable, again, needs to be interval or better for this to make sense. Let's continue along our investigation of M&M candies. Here we're going to take 20 adults, bring them into the lab on 2 separate days. On one day, this is a typo, should say on one day, the brown condition group will consume 30 brown M&Ms and then 20 minutes later complete a sexual desire questionnaire, which as you know is an interval measure. Same set of folks come back on another day, and in the green condition, they do everything the same as they did in the brown condition, except that the M&M candies are green. And because we're responsible here and we want to at least account for order effects, we'll have half of our participants do the brown condition first and then the green condition on another day, and the other half will do the opposite order, and we'll do that in a pseudo-random fashion. Just pseudo-random, meaning we're going to constrain this so that 10 will go brown-green and 10 will go green-brown, but you are randomly, within that constraint, randomly put into one of those 2 conditions. So here, we will again go to the compared mean submenu of analyze. paired samples t-test. Now we need to tell SPSS which two variables go together for the first pair. And for us, it's the brown versus the green M&M condition. Okay, let's pause for a second and come back to keep track of. So now each person is giving us a score for both the brown and the green. And so we run 20 people total, but we have 40 scores. Each person gives us a score for brown. Each person gives us a score for green. And what we're really interested in is whether there's a delta between the brown and the green. All right. So you can do lots of paired samples all at once, but we just have this one to do. We'll go over to our output. So now SPSS is telling us we're doing a paired samples t-test. The means actually are the same as what you just saw in the independent groups case, because in fact the numbers are the same for those two different conditions. We have a mean of 5.3 for the brown, a mean of 6.45 for the green. Now these ends are telling us how many scores we have, but the overall in here is 20, right? The same 20 individuals give us these 20 scores as give us these 20 scores. So we have our descriptive information, mean and standard deviation for the green condition, mean and standard deviation of the brown condition. We cannot worry about this for now. Paired samples tests. We have a mean difference of negative 1.15, same mean difference we had before, actually. We have a t here with 19 degrees of freedom that's equal to negative 6.33 and a p that's less than 0.001. We must have had a lot of individual differences here because we don't have a huge difference, but it is statistically significant. So here we actually have empirical evidence that green M&Ms do what everybody I know says they do. And isn't that always the case, that our intuition and our social knowledge fits with real data? So you can look at these and easily report that green M&Ms are associated with stronger sexual desire than brown. In fact, you could go further than that. Our study was a true experiment. You could say that the M&M color here caused changes in sexual desire. All right, so that's how to do the 3 different t-tests in SPSS. I thank you for watching. Take care.